Thank you, everyone. My name is Brian Lammers. I'm Senior Sales Support Manager here at PowerNet. We appreciate you taking the time to join us today for our discussion on public safety boosters. We hope today's presentation will be valuable to you. Just real quick, a few things about PowerNet. We are a full-service technology company, so covering technology for enterprises, MDUs, large businesses, mid-sized businesses. We really package all technology together on a single invoice with a single team as a point of contact for support, really for everything. So we simplify things, we eliminate pain points with having multiple providers, and really have grown our suite of technology solutions since our inception in 1992. Today, though, we will be focusing on the public safety signal boosters, which is really a service critical to commercial real estate firms, construction managers, building owners, and really any company that owns its own facilities. What public safety boosters do is they ensure that in the event that fire and police need to enter a facility to serve its occupants, they really have seamless communications with their teams throughout that entire event. I have Greg Gerber with me today. He leads our design and engineering team for public safety. Greg will cover our public safety booster service, how it works, and use cases. And with that, I'd like to hand it off to Greg Gerber. Thank you, Greg.
Thank you, Brian. I appreciate that. When I was in 6th grade, my dad was my history teacher. He was also my assistant principal at the time. And I remember a unit that we were doing on Asia where he hung a panda from the ceiling. And one day he came to us and said, I need to go up to the office for a little bit. But while I'm gone, I don't want anyone to jump up and touch that panda. So, naturally, being the son of the teacher and the principal, as soon as he walked out the door, all the other kids dared me to jump up and hit the panda. And being the stupid boy I was, naturally, as soon as I saw my dad leave, I jumped up to hit the panda to the cheers of every student in the classroom. But by the time I landed, there was total silence, and I noticed that they were all looking toward the door. What I didn't know is that my dad didn't actually go to the office. As soon as he walked out the door, he knew somebody was going to be stupid enough to jump up and hit the panda. He turned around and stood and watched me the entire time. To this day, my hand suffers from arthritis writing 100 times on the board, I will not jump up and touch the panda. I knew what the consequences were for my actions because my dad made it clear what we were not to do, but I did it. Think about in your life times where you've done things, there was consequences, but you truly did not know what the possibilities were, what you could get in trouble for, whatever it was. Maybe you're driving through a small town and there is a change in speed limit from 35 to 25, but it's a new town. You've never been in it. You don't know. So you say to the officer, look, I didn't know. I truly didn't know. You're expecting that there would be mercy in this case. They won't give you a ticket. So maybe they do, you pay the ticket. Or it could be anything where you truly didn't know. Fast forward to today, and now we are building owners, building managers responsible for operational budgets in a building where maybe businesses take place, you're conducting work, there are recreational activities going on, and now you are responsible for all the lives in that building. In the public safety arena, we know if you're a building owner or building manager, that you have to provide for ingress and egress for first responders. You have to provide for their movement on your campus. What you may not know is you also have to provide for their ability to communicate with each other while they're on your property. And those changes have been developing enormously over the last few years. So today, what we're going to do is try to help you understand and educate you a little bit on what you need to know about emergency responder radio coverage on your property and what your responsibilities are for providing that radio coverage. Most building owners don't know anything about that, but also most local jurisdictions don't understand it either. It's kind of a strange beast to them. Usually what happens is we don't know until there is an event that there is a need. 9/11 is the perfect example, and that's actually the catalyst for what's developing in public safety right now. In 9/11, over 300 first responders lost their lives, mainly due to the inability to communicate between departments or communicate with each other while they're on that property and they were working at the Trade Center. So that's kind of been the catalyst for all the changes that we are seeing taking place with emergency radio coverage in buildings. Last year in London, there was a young boy in school who had an allergy to dairy products. And his friend, as a joke, put cheese down his shirt. What he didn't understand is that that kid had a severe reaction to cheese. And in that particular case, he did. He went into anaphylactic shock. First responders are called. The first agent or the first person to come, while he's working on the child, realized he needed more help than what he could provide. So he tried to radio back to dispatch to let them know, I need paramedics, I need additional help. But he couldn't reach anybody, so he had to run outside the building to be able to get signal to reach back to dispatch for paramedics. And the boy, we can't say for sure that the boy died because of the inability to handle that situation immediately from a communication perspective, but it certainly did impact that. Later on, the boy died. Had he been able to spend those 7 minutes working with that child rather than running out of the building, perhaps the story would be different today. The sad thing is that even though that story was published, most folks focused on the bullying aspect of it rather than what do we do for our buildings? What do we do for our schools to provide the kind of coverage that those personnel need when they come in the building? So that's what we're going to be talking about today, is how do we address providing coverage in a building so that first responders, in the event that there is a life-threatening event, that they can communicate with each other while they're on the property and with dispatch. We'll talk about why that is becoming critical now compared to, say, 10 years ago, what's different with new construction as opposed to a few years ago, and why that's your responsibility rather than theirs. And so from the law's perspective, the local jurisdiction is responsible for towers, for radios, for user equipment, for personnel. They are responsible for managing the application with the FCC and managing that spectrum. But that's where their responsibility stops. They are not responsible for making sure that inside the building has coverage. That is, as a building manager, as a building owner, that is your responsibility. And so you have to be faced with, how do I know? I don't know. If the fire inspector comes in and tells me my building's fine, how do I know what to deal with? And why is it causing an impact on me now as opposed to in the past? If you are dealing with new construction, or you have an existing property and you need to do an addition, you can potentially be denied CO if your building doesn't meet the standards. So when the fire inspector comes in, it's getting ready to open and they walk around their building and they have no communication or it's spotty, they can deny CO for you. If you are a current building owner, you could be deemed out of compliance as your local jurisdiction updates your code to meet the standards that states have adopted. So those are things that you need to be aware of. So I want to talk about the standards that are being applied to the building, what the expectations are from those standards for your particular building, and how the jurisdictions are applying that. There are two that apply that every state is adopting. They'll adopt either one or the other, or some states adopt both. Ohio, for example, has adopted both of these. Florida is the same. NFPA and IFC 510 Both of them address the size of the building, the signal strength, cable runs, things like that. They're a little bit different in some specifics, but the things that they're the same on, 99% of all critical areas of your building have to be covered with a minimum signal strength. The critical areas include stairwells, entrances and exits, fire alarm control panel rooms, electrical rooms, things like that. The rest of the building has to have 90% coverage with that same minimum signal in all common areas. So it could be dining rooms, hallways, things like that. The minimum signal is such that a voice transmission could take place clearly with no more than one retransmission, is usually how they look at it. When NFPA also requires a 12-hour minimum battery backup, they also require a cabinet with a certain fire rating that has to be addressed. FCC has to be clearly labeled on the front of the device. And then they also address cabling, how the cabling can be run, the type of cabling that can be used. So those are all things that will impact your building and that you have to take into consideration when you're doing an emergency radio program. But I want to talk a little bit about, maybe you have an existing building. We have a customer up in the Cleveland area that we just did a survey for, and they have 7 buildings. It's a seminary campus, 7 buildings, some of them very old, but they got ready to build and do a $25 million expansion. So they're adding on to buildings, and they're adding a new building. The local fire chief told them as they began looking at the plans, I'm pretty certain you will need a public safety booster. In their case, well, why? We've been here for 100 years. We've never had this issue in the last 20 years. Well, in order to meet the updated standards, they have to comply with that now that they're doing this expansion. And the fire chief happened to know us from another job, said, please go in. We've done that and found that all 7 buildings did not meet current standards. So they have to plan to address that. The reason for a lot of this is there's a LEED certification. If you're a construction manager and you're building to what's called LEED certification, you're building with certain materials that, with metal or certain types of concrete that impede signal from entering your building. You would normally think, well, it could penetrate through the glass. But in most cases, you're also using what's referred to as a low E glass that has certain types of metal, usually silver, in it, that will force signal to not be able to enter the building. So it is repelled away from the building. When signal does enter the building, depending on how the building has been built, usually with metal studs, that will also impede signal from being able to propagate inside the building. We were doing a facility in Boca Raton. Outside, the signal was phenomenal. The first responders could communicate with each other, back to the dispatch, no problem whatsoever. As the building was enclosed, as soon as the windows went in, when we went inside the building, they had no signal anywhere in the building. Those are the types of things that are happening. So even if you have an existing building and you are doing an addition or renovation, you have to take into consideration the possibilities of problems with signal. So if you're building, you have a call like the guys up in the Cleveland area, the fire chief says, you more than likely will have to have a public safety booster. What do you do? Who do you call? How do you handle that? What are the steps that you would go through to determine how you put in a booster and how you determine where it needs to cover, those type of things. So first I want to talk about what a booster actually does. Brian mentioned a little bit in the beginning that it is taking signal from outside, amplifying that throughout your building. So what it's doing is there's an antenna that's placed on the outside of your building. All that does is receive signal from the first responders network, whatever their closest tower is, It brings that signal into your building via a coax cable to a NEMA 4 certified box that is in a 2-hour fire rated room. And that box then distributes that signal throughout your building with low profile antennas. And those will all go to the correct locations. They will also cover the proper frequencies for every first responder in the country, or every emergency agency has specific uplink and downlink spectrum frequency that is given to them by the FCC that they control and they have to manage. The boosters that we deal with will cover all of those frequencies across the entire country. Not only that, they also cover what's called FirstNet. So FirstNet is a network that was built out by AT&T that allows first responders to use a cell phone on an LTE network. And so that they're in a building, they can use their cell phone or they can use their two-way radio, walkie-talkie. So the boosters that we put in will boost both FirstNet and two-way radio signal in that building. So you don't have to do two separate systems. You have it all covered in one. The process that we go through when you get a call like our customer up in Cleveland or in Asheville, North Carolina, we just did another site survey. The fire chief told them that they wanted to have CEO in November. They said, more than likely, your building will not meet spec. It won't meet the standard. And we went in there. So what we did with this customer, we started right off the bat with them. We talked to the local jurisdiction, found out what the frequencies are we need to cover. That's the first step for us as a discovery phase. We find out the frequencies, tower locations, and anything that is specific to that local jurisdiction that maybe supersedes what NFPA and IFC standards are. That's number one, determine type of booster that would be needed in that area. Then we go on site with a signal meter, walk the outside of the property, go inside the property, and check every single area of that building for a minimum receive signal that meets the standards, either IFC or NFPA. Then we document that on a map, create a report off of that that shows clearly how cable needs to run, where the 2-hour fire rated room is, where fire alarm control panel is, and where all of our antennas will go and what signal would be like after it's boosted. So you know, after our survey is done, you will have a report that shows every area of the building and the coverage that you should expect. The next part of that process is an implementation, and that is coordinated with the owner, so with you, with manager, electrical contractor, also with the local jurisdiction. When a system is designed and placed in a building, the final step is to have the local fire team come in, about a 2-hour process, walks your entire building, tests their two-way devices, and makes sure that they don't have to do more than one retransmission on voice. They will do that with us, and then they sign off that the system passed and was good to go, certified. Last after that is filing with the FCC using our number or the local jurisdiction's number so that that device is filed and FCC knows where boosted signal is taking place. That's the normal process that we go through. Typically, site surveys take 1 or 2 days, depending on size of building. 300,000 square foot building may take a day and a half. Less than that could be less, but normally it is a complete process that we do totally in-house. Some companies may come in and they will only do a site survey. They're very good at it. They have RF engineers that do that, but they don't do implementation. With us, you are with us from start to finish. So from educating you on what the need is, going through the process of helping you coordinate with the local jurisdiction, site survey, design, implementation, and installation, coordinating with the local jurisdiction, and finally filing with FCC. That is us all the way through from start to finish. And it gives you a lot more confidence in the finished product that you're going to be able to do that. So we've set this up today so that we have time for additional questions, or we've shared our contact information at the end, both Brian and myself, that you can contact with questions should you have any about any part of the process or what we can do to help you out. Thank you.